Okay, this Bharadwaj is active or not? I don't know because he is not responding.
Yes, sir.
No, Dev Bharadwaj.
Right, sir.
Dev Bharadwaj, are you there? Okay, Dev Bharadwaj is not. So I want to make co-host because in case if light goes off and all this happen, internet connectivity and all this. Please suggest name to whom I should make a co-host. Anyone ready to become a co-host? Jatin, are you there, Jatin?
Yes, yes.
Okay, I'll make you co-host. Okay.
Okay, sir.
Jatin, where is Jatin? Make co-host. Okay. So you please allow other students, okay, in the room. Please check their number and all this thing and allow them.
Yes, yes.
If you have any confusion, then you can please ask me for any person if you want to enter. Don't deny
Okay, sir.
the request. If you are in confusion, please ask me. Hope I am loud and clear to you, to all of you.
Yes, sir.
Okay. Now this is the first lecture, okay, of a basic thermodynamic. I taught you, I think, drawing or some other subjects, okay, in the last semester. And in the practical session also, I will be with you for the drawing. So let me introduce myself, Dr. Madiwale from Mechanical Department. And the subject will be shared by two more faculties. They're called Mr. Sachin Ilag and Mr. Prasad Deshpande with me in this semester. For division 1, 2, I will be with you. For 3, 4, Mr. Prasad Deshpande is there. And for 5, 6, Mr. Sachin Ilag. So 3 different faculties teaching the two different divisions, the same subject. And this is the basic fundamental subject, so it is not possible for us to divide or distribute the topics horizontally because dependency of the topics are there on each other. So because of that, we require to move from basic concepts, and the units are linked. So parallel through faculty is not possible to teach this subject. So we required to understand the first topic, then we can jump on second, third, like that. So it is a fundamental subject. So it is not possible. So before moving into the depth of this entire topic called as a basic thermodynamic and subject basic thermodynamics and unit, we will discuss. I like to discuss the one document which I already shared with you. That is called as, my screen is visible to all of you? Is my screen is visible?
Yes, sir.
Okay. So I want to discuss this document. The name of this document called as course handout, called as a CHLP. That is a 1 minute. That is called as course handout and a lesson plan. And this particular document tells us about the distribution of the different topics and what are the different topics what we are going to cover in this particular subject. This basically gives us the broad idea about the different topics and the prerequisites also. So this document is already uploaded on the Moodle, that is called as LMS, TMI LMS. So I request all of you to please maintain one folder of basic thermodynamics. Whatever the documents used to get uploaded on that Moodle, please download that document and store it into your particular folder, so that you at the end you will not rush here and there in order to search for the document. Okay, so at the end of every unit, I generally used to upload certain notes, the question bank. So if it is a very good practice to all of you that if you download and store it, it will help you at the time of end semester examination. I think all of you also know this thing, that end semester examination this time is the what we can say offline. So so MCQ will not be there. Obviously, what we can say, or we come to know that the MCQ may not be there. So we need to understand the subject very thoroughly. Okay. So the nature of the subject is not totally theoretical, is not totally numerical, but maximum weightage is on numerical, 70% numerical and 30% theory. Okay, theory means the theory and the derivations. So the important objective of this basic thermodynamic to impart knowledge to the student. And in each and every semester, you have one subject which is connected to the basic thermodynamics, such as applied thermodynamics 1, marine steam engine, internal combustion engine, power plant engineering, computational fluid dynamics, fluid mechanics. So all these subjects required a strong understanding and the foundation of the basic thermodynamics. So this is the most important subject of your curriculum. Okay, we can say in this way. The CHLP is having the 4 different what we can say part: general learning objectives, teaching aid, subtopics, and the specific learning objectives or evaluation criteria. So if you maintain a notebook and at the end of each and every unit, if you are able to understand and if you are able to find out the answer to this question, then slowly your notes will also get built up. So I suggest that whatever the questions are mentioned in the evaluation criteria, take one question and from the notes, from the textbook, from the online notes, from on the LMS and the Moodle, try to give the answer to that particular notes, to that particular question. So if you solve in this way, then obviously what will happen, your ready-made notes will be get prepared. So in the topic number 1, so throughout the semester, I will conduct the 45 lectures, then 15-hour tutorial classes. So contact hours are 61. It is not possible to cover 6 to 7 units. in the 60 hours, more than 60 hours we need to engage in order to complete the syllabus, because numericals are variety type of the numericals are there. Okay. So here, the first topic is related to the application areas of the thermodynamics in maritime industry and the thermodynamic definition. For this, we will try to understand the terminology we generally used in the basic thermodynamic, such as the closed system, open system, isolated system, adiabatic system, homogeneous system, macroscopic and macroscopic point of view, properties of system. In the 11th and the 12th standard, you already learned this few topics, but at that time the depth was very less. But here, as per the maritime industry application, the depth, we have the sufficient amount of the depth with respect to the treatment called as theory and the numerical. So don't be in the impression that although we already covered this topic at 11th and 12th standard, so no need to study in one day, prior to one day, you will get the knowledge. Not like that. You always require a strong foundation, strong understanding of each and every point associated with these fundamentals and the numericals also. So in the unit number 1, we'll try to explore the basic terminology we generally use now and then in the thermodynamic. In the topic number 2, that is called as energy transfer and general energy analysis, we'll try to understand the different forms of energy: kinetic energy, potential energy. Then main 2 forms of energy called as heat and work. So energy transfer by heat and energy transfer by the work, and mechanical forms of work. Then the most importantly, the first law of thermodynamics and application of first law of thermodynamics to the flow system and the non-flow system. This will cover in the topic number 2. In topic number 3, we'll try to understand the properties of the pure substance. That will conversion of water into the steam, and the associated terminology. We'll also use the steam table. Steam table, they are allowed to use, you can use that steam table directly in the examination hall itself. You can carry that steam table, or examination department will provide you the steam table at the time of examination. But you should have one copy of the steam table.
But your voice is lagging.
But you should have one copy of the steam table. I will request the library person, okay, to distribute you the steam table shortly. So in the topic number 3, we will try to cover the properties of pure substance. We'll also try to understand the different phase diagrams, PV diagram, the TS diagram, the HS diagram, the property tables, and different regions associated with the property diagrams. So this is also very, very most important topic inside this particular subject. Then the 4th topic is energy analysis of closed system. This topic number 4 basically moves in hand with the topic number topic means unit number 1 and unit number 2. Basically on unit number 2 we can say. So unit number 2 and unit number 4 will move parallelly with each other. Okay, because a few topics from unit number 2, if you want to cover, then you need to understand the topics from unit number 4. So parallelly, the unit number 2 and unit number 4 will go hands in hands. So when we cover the unit number 2 completely, that means half of the unit number 4 we already covered at that time only. Okay, so no need to have the separate treatment for unit number 4. So in this topic, we'll try to understand moving boundary work, energy balance for closed system, internal energy, enthalpy, specific heat for ideal gases, internal energy, enthalpy, specific heat for solid and for the liquid. Then, am I audible to all of you?
Yes, sir.
Then the topic number 5 is associated with the mass and energy analysis of control volume. This basically related to conservation of mass and the application of first law of thermodynamics to the flow system. The systems are classified into the 2 categories, flow and non-flow. Non-flow system means the piston and cylinder arrangement where we don't used to have any inlet and the outlet. In cylinder, we'll have the working fluid, and the piston basically used to compress that fluid with the help of the expansion work and compression work, and release it with the help of the expansion work and with the help of compression work, it is to compress it. Flow system, where we have the inlet and outlet. So how the fluid behaves, how energy transfer takes place, how the work get converted into the heat, how the heat get converted into work. All these things we learn in this particular topic number 5. Topic number 5 is basically moves in hands with topic number 3, that is properties of pure substance. Okay, so when you cover the topic unit number 3, half of the unit number 5 will already cover. So unit number 2 with unit number 5, and unit number 3 with unit number 2 with unit number 4, and unit number 3 with unit number 5. Okay, so dependency of topics are there. Then after that, we'll move into the second law of thermodynamics. We'll try to understand the application of the first law of thermodynamics to the closed system, to the open system. We'll try to understand different applications also. After that, we'll try to understand the limitations of the first law of thermodynamics. And after understanding the limitation of the first law of thermodynamics, we'll move to the second law of thermodynamics. Okay. So second law of thermodynamics, this is in the unit number 6. What is second law of thermodynamics? The different applications of the second law of thermodynamics, that is a heat engine, then heat pump, refrigerator, Carnot cycle, Carnot principle. All these things we'll learn in the topic number 6. In topic number 7, that is the extended version of the unit number 6, that is called as entropy. Here we'll try to understand the TDS relation, entropy change of liquid solid, okay, and also entropy changes for the ideal gases. So we'll try to understand all these things in the unit number 7. And at last, we need to concentrate on the exergy, that means available form of energy, where the heat we are able to convert into the useful work. That basically called as the availability. So exergy is also called as availability. So we have the total 8 number of units, and for each and every unit, okay, very particularly the evaluation criteria for each and every topic is mentioned. So after completion of topic, if you try to solve, if you try to answer all these questions, your notes will get ready side by side. So up to what depth we are going to cover that topic, by looking towards this number of questions also, we will come to know at up to what depth we are going to cover that particular topic. So this is important to go as per the CHL. Okay, I will move as per the CHLP in each and every lecture. After that, the few books are we mentioned as textbook, but probably we'll use the textbook called as Thermal Engineering by the R.K. Rajput. Okay. Then in addition to that, you can refer the PK and also the thermodynamic and engineering approach by Eunice Chenjal. All the soft copies of all these books are available on your Moodle. All the soft copies are available on the particular Moodle. So you can download that soft copies and store it in your laptop in a basic thermodynamic folder. Other than that, some reference books are there, but I think if you move with these 3 books, I think it is more than enough at first year level. Evaluation program, entire evaluation program for this is a class test 30% and final exam 70%. And this time the exam is offline. Okay, so try to solve the maximum numericals. Okay, I will float now and then, I will float the assignment to you, the numericals. So you need to solve all these numerical and assignment and upload it on the particular Moodle. Okay, so this is all about our the course. The course is, the depth of the course is very good. You must able to what we can say, you must able to classify the different numericals in the different units. Prior to the examination day, prior to 1 week, if you start studying this subject, then the problem in that you will feel like that this problem may be from unit number 1 or maybe from unit number 2. So there will be a lot of confusion. in which unit you require to take that particular problem. So daily, if you study this subject for 10 minutes or 15 minutes is more than enough. Whatever topics we covered in each and every lecture, if you revise that topic and depend on that topic, if you solve few numericals, then I think it is more than enough for you to avoid all such type of confusion at the end. But if you are studying this particular subject entirely at the near the end or prior to 1 week of the examination, then there will be a lot of confusion in your mind, because each and every numerical look like same. Okay, little bit here and there that data, and depends on that data you need to take a call whether to solve this problem as per the fundamental of number 2 or 3 or 4 or 5. Okay, so this is the importance of this particular subject. Now, okay, any doubt about this? Any doubt about CHLP or anything you want to convey or anything you want to ask? Yes. Anyone?
No, sir, no doubt.
No doubt. Okay. Okay. Thank you. So if you visit to LMS, you will find out this particular CHLP. At the same time, in the LMS, there is a one folder called as class notes by Dr. Shrikant Madiwali. So you need to refer that folder only for my notes. I will upload all the notes, detail, okay, all the things in that folder only, because the other faculties will upload their own notes for their other division also. You can refer that also, no problem. But whatever the things we'll discuss in the class and whatever the assignment and other things are, if our notes I want to give to you, I will upload in that particular folder. So please refer that folder only, that class notes or the notes by Dr. Shrikant Madiwali. Okay, like that. Okay, moving on the first topic, that is called as application areas of thermodynamic in maritime industry and a thermodynamic definition. So when you going to talk about a thermodynamic, what is exactly been the thermodynamic? Thermodynamic is obviously what we can say, it's a science of energy, especially heat and work. So when you going to talk about the energy, it's a heat and work, and it basically deals about how the transfer of energy takes place and affects the properties of material. The picture is self-explanatory. Okay, we are taking the food, the work basically takes place, it get converted, it will move into the form of energy, and we will become the food for others. So there is a conservation, what we can say, the conversion of energy from one phase to the other phase, from one form to the other form. Specifically in the basic thermodynamic, this energy we call as heat and work. So the thermodynamic is the science of energy, that is called as heat and work, and how the transfer of energy affects the properties of the, what we can say, the material. The objectives of this particular unit is to identify unique vocabulary. That is very important, because this vocabulary we'll use now and then in each and every lecture and in the numerical there itself. So we need to understand that vocabulary. So identify the unique vocabulary associated with the thermodynamics through the precise definition of basic concepts to form a sound foundation for the development of the principles of thermodynamics. Explain the basic concepts of thermodynamics such as system, state postulate, equilibrium, the process, and what we can say, the different cycles. And we'll also try to understand the systematic problem solving techniques. Okay. So when you're going to talk about the thermodynamic and energy, the thermodynamic basically related to it's a science of energy. Just now we define what exactly mean the thermodynamic. It's a science of energy. And what is the energy? Energy is nothing but called the ability to cause changes. The thermodynamic name itself gives the idea about these changes and energy transformation. It's a what we can say Greek word. It's a combination of two Greek words, that is thermi, that is heat, and dynamics, of power or its motion. So it is called the heat and power, and or we can say heat and motion. And the word comes to picture that is called as thermodynamics. So here, if you take the example of this particular cliff, and if you have the stone at this place having some potential energy of 10 unit, then kinetic energy is equal to 0. So total energy is equal to 10 plus 0, that is called as 10 unit. When the stone hits the ground, then the kinetic energy will be the 10 unit and potential is equal to 0. 10 plus 0, again, what we can say, it's a 10 unit. When it is in between, potential energy is 7 unit and kinetic energy is 3 unit, again addition is 10 unit. That means everywhere the energy is same, 10, 10 and 10. What that means? That means energy is same. The total amount of energy, it remains constant, whether it is at position A, position B and position C. Only the form of the energy changes. Maximum potential energy, zero kinetic energy, potential energy get converted to kinetic energy, maximum kinetic conversion takes place. Kinetic energy is more, potential energy is minimum. So conversion takes place, but what about the energy? Energy at point A is equal to energy at point B. A is equal to energy at point C. What that means? That means during an interaction, energy can change from one form to another, but the total amount of the energy remains constant. What is this? This is called as conservation of energy principle. We can't generate the energy, we can't destroy the energy. So the first law of the thermodynamic is an expression of the conservation of energy principle. How one form of energy get converted into the another form of energy, provided that the total amount of the energy remains constant. The first law asserts that the energy is a thermodynamic property, and that's very true, because when we are talking about the property define the system, or in order to define a system, we require certain fixed amount of the properties, and the system which contain the energy, then obviously that particular energy we can call a thermodynamic property. Now there are the certain limitations of the first law of thermodynamics. What are the limitations of the first law of thermodynamics? First law of thermodynamics not gives any idea about the direction of conversion of energy. That means the conversion takes place, but up to how much time is required for that conversion, we don't know. How much quantity get converted from one level to the other level, we don't know. So as per the law of nature, the energy is always always flow from high potential to the low potential, and that basically uses the direction of decreasing the quality of the energy, unless and until we not establish the equality between the two sources. That means it asserts that energy has a quality, that means magnitude, the high or low, and as well as the quantity. Quantity means its content. And actual processes occur in the direction of decreasing quality of energy, and because of that, the second law comes to picture. The second law gives us the idea about the conversion of, about the direction of the conversion of energy, and how much energy get converted, in which direction get converted. That particular input, the second law basically gives us. What is law of nature? Law of nature is to convert the energy from high potential to the low potential, unless and until there is not any significant, unless and until the equilibrium will not exist. But prior to equilibrium, the conversion takes place, high to low. That means suppose there is the waterfall. All of you with me, getting or not? Yes or no, please?
Excuse me, sir.
Yes, yes.
Sir, how are we supposed to make the notes? Like we have to write this?
No, I will share this notes to you. The important part, what you feel, you can write down.
Okay, sir.
All of you with me, yes or no, getting or not? Any question up to this? Hello?
Yes, sir.
So, the law of nature is to convert the energy from high potential to low potential. So, suppose if you take the example of the waterfall, okay, the water start to move from a high potential head to the low potential head. Okay, very easily. We don't require any external agency or any external power to start the flow of water from high potential to low potential. Automatically, law of nature. Take the example of heat. Heat always flows from high potential, a high temperature gradient to the low temperature gradient, or high temperature to low temperature. We don't require any external agency to, in order to start the heat flow. We don't require any external agency to start the flow of water from high potential to low potential. But if you think in the reverse direction, if you think in the reverse direction, is it possible naturally to lift the water from low potential to the high potential? Is it possible? Is it possible?
No, sir.
It is not possible. We require some external agency. We require some external power in order to lift the water from low potential, from low head to the high head. And for that we employ the pump. At the same time, if you want to withdraw if you want to drop down the temperature of any room, we need to employ the air conditioner or blower, so that there should be drop down in temperature. So this direction is very important. If you don't know the direction, it will take infinite time period. Okay, you will think that the water will lift up in infinite time period from low potential to high potential without consuming any type of water. It is not possible. And first law basically not gives any idea about the conversion of quality of the conversion, and as well as the quantity of the conversion from one location to the other location, or from one process to the other process. And that is the basic limitation of the first law. These limitations are identified by the Kelvin and the Planck's, and Kelvin and the Planck's gives us the two statements, and these two statements basically we call as second law of thermodynamics. That is Kelvin-Planck statement and the Kelvin-Planck statement and the Clausius statement. Kelvin-Planck, that is the two scientists give one similar statement, and Clausius give the one statement. Both basically gives us the idea of the second law of thermodynamics. Okay, is that clear to all of you about first law and second law? Any doubt?
Sir, in the second law, this means direction of decreasing quality of energy.
Yes, in the second law basically tells us that the direction of decreasing the quality of energy always moves from high quality potential to the low quality potential. When high quality potentials are there to low, and if you know, and low quality potential if you know, then you can decide the direction. And even if you know these two, and if you want to reverse the process, you will come to know that some extra agency you will require to employ in order to get happen the reversible process.
Okay, sir.
Okay, so any doubt in the first law and second law? Can we move further? अरे आप है कि नहीं, या सिर्फ आप ऑन करके बैठे हैं?
No, sir, no doubt.
No doubt.
Why you are not responding? I am not listening. Or is there a lag?
No, sir.
Okay. Otherwise, then I will ask you to switch on your videos. Okay, please respond. Now, there are different approaches to study this thermodynamics. First approach we generally call as the classical thermodynamics, and second approach is called the statistical thermodynamics. What is classical thermodynamics? Classical thermodynamics is also called as macroscopic approach to the study of the thermodynamics that does not require a knowledge of the behavior of the individual particle. So when you are saying that temperature, suppose if you switch on the air conditioner and you set the temperature to the 70 degrees Celsius, so everywhere you will never get to 70 degrees Celsius or 19 degrees Celsius. But by an average itself, the average temperature of the room is 19 degrees Celsius. So it's what we can say. It's we don't require the behavior of the individual, temperature of the individual, the particles inside the room. It's the average temperature. So behavior of the average particles we want. So that type of approach we call as a macroscopic approach. And throughout your study from first year to the final year, we always use the macroscopic approach. Only in the mass transfer, chemical transfer, we use the macroscopic approach. Second approach is called statistical thermodynamics. That is called a macroscopic approach, where it is based on the average behavior of large groups of individual particles. That means, suppose take the example of a air conditioned room, and if you put on the air conditioner and you want to maintain a temperature 90 degrees Celsius, then near the air conditioner temperature, you will get a temperature 90 degrees Celsius, but near the wall, the temperature may be 20 degrees Celsius. Near the glass wall, it may be 22 degrees Celsius. Okay. So the average behavior of large individual group of particles, if you are interested into that, or if you are trying to understand their behavior in a group, in a pockets, in a particular room, then or in a system, then that type of approach we generally call as the macroscopic approach. Unless it is not said, we'll never go for the statistical thermodynamics or macroscopic approach. We'll always go with the classical thermodynamics. There are different applications. There are different application areas of thermodynamics, such as in our household itself, you can find out different application, like the water pump. The pump used to take the water from low head to the and deliver that water to high head. It's the energy reservoir, high head potential and low head potential. Then your refrigerator, your electric fan, your TV, your human body. So everywhere, when you look here and there, okay, whenever temperature gradient and flow of energy takes place, you will find that all these are the applications of thermodynamics. In the shipping, the motion of ship itself is the application of thermodynamics, because buoyancy plays a very, very important role. Motion of propeller, motion of the rudder, the engine, you are converting the chemical energy of the fuel into the mechanical energy. Then a boiler, you are converting the water into steam, and you are using that steam in order to produce the power. Then what we can say, the pump, different types of centrifugal pump. So you name the machinery, okay, which is on deck itself, or in the engine room, you name that machinery, you are able to categorize that application, that machinery as an application of thermodynamics. So it is not possible to escape through the application of thermodynamics. Everywhere you will find out the application of thermodynamics. So while moving to the application, we need to understand the basic fundamental concept which are associated with this particular thermodynamics, such as system and control volume. What is system? This we generally call as the system. Okay, let me connect. This is called a system. System. What system? A system is nothing but called as a quantity of matter or region in a space chosen for the study. So it is not possible to take entire universe for the study. We need to put somewhere boundary, no? And by putting some boundaries, an envelope will be created, a system will get created, and that region will come for the analysis. So that region we call as our system. Whatever outside is there, that is called the surrounding, and in between what we are having the boundary. Boundaries are classified into different categories: fixed boundaries, moving boundaries, real boundaries, imaginary boundary, depends on the application. So if you have this particular piston and cylinder arrangement, if you have the gas of 2 kg, whose volume is 1 meter cube, and here the volume is 3 meter cube, because we added the heat into the cylinder, and when you added the heat into cylinder, then obviously the gas will get expand, volume get increased, it will do the work on the piston will move in the upward direction. When the piston moves in the upward direction, this boundary will move in the upward direction. But what about others? Fixed. Okay, but this boundary is what we can say moving boundary. In case of balloon, all boundaries are moving boundary. Okay, here balloon with helium. Okay, just simply release that balloon, it will move in the that much, all the entire shape of balloon or entire boundary which enclose the balloon. Okay, all the boundaries we consider as a, we can say as a moving boundary. So the boundaries are can be a fixed one or we can say movable. What is surrounding? Surrounding a mass or region outside the system. And if you add system plus surrounding plus boundary, then what will get? You will get the a universe, entire universe. These systems are classified. Basically, the systems are classified into the three different categories.
सर गए क्या?
सर क्या इंटरनेट चला गया?
क्या बात है, राउटर होगा ना।
इधर तो लाइट चल गई। क्या हाल है?
अभी आएंगे सर।
हाँ
जगताप बॉय। Do you know? जतिन मारता और होस्ट।
प्रथमेश सर, गुड इवनिंग।
गुड इवनिंग प्रथमेश। बोलना।
अरे ये बच्चा कौन दिख रहा है?
Hello, am I connected?
Yes sir.
Okay, can you make me? Thank you. There was some problem, okay, of net problem here in campus. 1 minute. Okay. Am I audible?
Yes sir.
Okay. Now this we call as the universe. So if you add system, if with the surrounding and the boundary, then we'll get the universe. These systems are classified into the different category called as closed system, which we generally call as controlled mass. Then we can say the open system and the isolated system. Closed system we generally call as controlled mass. So here the system is there who's having the fixed mass, who's having the fixed mass, that is m is equal to the constant, that is called as the closed system, because all the boundaries are closed. And suppose if you add the heat into this, then we are allowed to allow the exchange of heat from system to surrounding. So energy transfer is allowed from system to surrounding or surrounding to system. But what about mass transfer? Mass transfer is not allowed. Now such type of system is generally called as closed system or control mass system. Now take the example of your pressure cooker. Okay, pressure cooker. We'll have the vessel here itself. And with respect to rice, if you have rice and water here itself, the two working fluid, with respect to rice as a working fluid, okay, we'll have the rice and water here itself. And if you start to add the heat to the pressure cooker, then after some time, the water get converted into vapor and vapor will move out of the system. So there is a transfer of heat or energy from system to surrounding. But what about rice? Rice is there. We are not allowed rice to move out of the pressure cooker. Okay. That means the mass transfer is not allowed, but energy transfer is allowed. Considering in the pressure cooker example, rice as a working substance. If you consider water as a working substance, then there we can say it's a open system. Okay. Okay. Now next, this is called as your control system, a closed system, that is control mass. Second is nothing but called as your open system.
Sir,
Yes,
can
please.
you explain once again about the closed system?
Okay. Closed system. This is closed system. We have a piston and cylinder arrangement. We have the closed system. We have the certain gas whose mass is constant inside the closed system. We started to heat this system, and all the boundaries are fixed. Suppose take example, all the boundaries are fixed. Then whatever the energy this particular system receives, we allow the transfer of this energy to the atmosphere or to the surrounding, or we are allowed to take the energy from surrounding inside the system. So energy transfer is possible. But what about the mass? Mass is constant. We not allowed the motion of mass, okay, motion of the mass of that gas, okay, outside the system, or no mass will enter inside the system. Take the example of this pressure cooker. In the pressure cooker, we'll have the vessel itself or the pressure valve. Then we have the container, and inside that we will have the rice and water. We will treat rice as a working fluid having a certain mass there itself. Okay, not water. And when you start to add the heat towards towards this pressure cooker, then what will happen? Water get converted into the steam, and steam will move out of the system. That means the entire system receives the energy, and that energy get released into the atmosphere through that particular vessel. So energy transfer is there, but what about rice? Rice is there as it is. The water vapor, they are moving outside the system. But what about rice? Is the rice is moving out of the system? No. Only water vapor is moving out of the system, and we are utilizing that energy to cook that rice. And excess particular water vapor, they are moving out of the system. So with respect to rice, it's a closed system. But with respect to water vapor, it's a open system. Why? Because in the water, in the water vapor, or in the what we can say open system, both this particular mass and energy we allow to interact with the boundaries and with the surroundings. Suppose an example of geyser. This is the geyser, electric geyser, water heater. You are taking cold water in the system. You are taking cold water into the system. The process takes place in the water heater. You are going to switch on this particular electricity. Okay, it will get heated up. Then what will happen? Water get converted into the hot water. Not only in the hot water, but also get converted into the water vapor, and hot water and water vapor moves out of the geyser. What happened? Mass of the water, cold mass, okay, of the cold water entering into the system, and mass of the hot water moving out of the system. So there is a mass transfer, yes or no? Yes or no?
Sir.
And at the same time, cold water moving in and hot water is moving out. So there is energy transfer also. So both mass and energy we allow, okay, to transfer the boundaries of this particular system. So this system is then we call as control volume, or we can say the open system. Maximum applications in thermodynamics are associated with the open system. Take the example of the pump. Okay, what is the function of pump? Function of the pump is to deliver the water from lower potential towards the higher potential. That is function of pump. So water is moving into the pump at low head, and at high head the water will get delivered by the particular pump. So water is moving in, water is moving out. So mass transfer or mass interaction, mass moves in the system, mass moves out of the system, and at the same time this particular energy at low head is different than energy at high head. So energy transfer also takes place. Take the example of the compressor. Okay, in the case of compressor, you are filling, many times you visited this cycle wala shop to fill the compressed air into the tire tube. So function of the compressor is to take the air, atmospheric air, to compress it, to store it, and to pump it, okay, into the your tire. So here compressed air at different energy level, at different pressure, is moving from atmospheric pressure, and moving out at different pressure, at higher pressure. So air is moving out of the system, is it? And the pressure of that air at inlet is different than pressure of air at the outlet. So that means the both mass and energy transfer takes place. Getting all of you with me, yes or no, please?
Yes, sir.
Now last one is called at the isolated system, and in the isolated system, we not allowed any interaction of a mass from system to surrounding. Mass we not allowed to cross the boundary, and also the energy. And the thermostat, the ice plant, all these are nothing but called as the your isolated system. The control surface, okay, the boundaries of a control volume basically we only call the control surface, and this can be a imaginary, or what we can say the real boundary. Suppose example nozzle. In the case of nozzle, we'll have this boundary, we'll have this boundary. So this is called the real boundary. But here the properties are different. At inlet, properties are different. And at
Sir,
here also.
can you please explain open system again, because I got disconnected?
When
When
we allow
when you
the
start explaining.
okay. When we allow the transfer of or interaction of this mass from system to surrounding, or surrounding to system, and also energy also transfer from system to surrounding and surrounding to system, then that type of system is generally called as open system. In the case of water heater, cold water moves in, hot water moves out. Water moves in, water moves out. Mass transfer from system to surrounding, and at the same time the energy transfer also, because cold water at low temperature and hot water at high temperature moving out of the system. So energy transfer. So that system we call as open system. Got it? Hello?
Yes, sir. Yes, sir.
Okay. So in the case of imaginary boundary and real boundary, okay, so take the example of nozzle. Nozzle will have the fixed boundary. This boundary and this boundary. So this is called as the real boundary. But what about this boundary? What about this boundary? The properties are different at this boundary and at this boundary. But we don't have any material. ये सपोज प्लास्टिक का नोजल है, तो यहाँ पर प्लास्टिक है क्या? नहीं है. यहाँ पर प्लास्टिक है क्या? नहीं है. प्लास्टिक तो यहाँ पर है, प्लास्टिक तो यहाँ पर है, और यहाँ पर तो नहीं है. But properties are different because of the shape. So this boundary and the properties are different because of the shape, because of the other parameters, the boundary form, and this boundary we call as imaginary boundary. These are the imaginary boundary. No need. Okay, not necessarily that at each boundary we should have what we can say the material. Okay. Getting all of you with me? Yes or no, please?
Yes, sir.
Okay. So in this lecture, I think what we learned what exactly mean the thermodynamic. Then we try to understand the energy, thermodynamic and energy, then conservation of energy principle, then first law of thermodynamic also we try to understand, then second law of the thermodynamic, why there is a need to have the second law of thermodynamic. There is also third law of thermodynamic also there. The temperature never be equal to 0. Okay, temperature, that is T, temperature of the never be equal to 0. It is not possible. It can be the temperature of the source, or it can be temperature of sinks, but it never be equal to the 0. That is called the third law of thermodynamics. Okay, we'll talk into the unit number 6 about that. Then we talked about the two different approaches of the thermodynamic, that is called classical thermodynamic and statistical thermodynamic. Then different application areas of thermodynamic we try to understand. Then we talked about what exactly in the system, the surrounding, the boundary, the fixed boundaries and movable boundaries. Okay, the systems are also classified into the three different categories: called as closed system and open system and isolated system. In the closed system, we not allow the transfer of mass. A fixed amount of mass must be there, and no mass can cross its boundary. But energy, we allow the transfer of energy, okay, or energy can cross the boundary of the system. So that's we call a control mass. Okay, control mass means closed system. Control volume means open system. In the control open system, both energy and the mass, okay, we allow to cross the boundaries of the system. Isolated, no interaction. Okay, we not allowed mass and energy to cross the boundary itself. Okay, then the boundaries are also classified as real boundaries and the imaginary boundaries. We just now discuss about that. So this is all about the what we can say your few basic fundamental concepts about the system and the control volume. Now, when you're going to talk about this system, we require certain parameter to define the system. Okay, and we just now in the statement of the first law, we come to know that property, energy we treat as a property of a system. But what exactly mean the property? What exactly mean the property of a system? Property of a system is any characteristics of a system. It can be a pressure, it can be temperature, it can be energy, it can be a volume, it can be a mass. Any property of a system or any such type of the property we define a system, okay, is nothing but called as the property, or any entity which is able to define a system is we call the property. So energy defines the system. So energy we call as the property of the system. Properties are classified into category intensive properties and extensive properties. Intensive properties are those which are dependent of the mass of a system, such as temperature, pressure, density. Extensive properties, those who have the values which are dependent on the size or extent of the system. That is called as extensive properties. Or the property which are not dependent, which are what we can say dependent on the mass of the system, called extensive property, which are not dependent on the mass of the system, called as intensive property. Temperature, pressure, and all these things. Specific properties, extensive properties per unit mass. Nothing but called as your specific property. That is a volume. Okay, volume divided by per unit mass. V by M is nothing but called specific properties. Take the example density. What is density? Mass upon volume. Specific volume, that is small v, is equal to volume upon mass. That is extensive property divided by mass is equal to 1 upon rho. That is 1 upon density is equal to specific volume. Specific gravity. The ratio of density of a substance to the density of some standard substance at a specified temperature is nothing but called as the specific gravity. Specific gravity is equal to rho upon rho of H2O. Take the example, if the volume is 12 meter cube, total volume is 12 meter cube, then, and if the mass is 3 kg, then what is the density is 0.25 kg per meter cube. Okay, M by V. But what is specific volume is 4 meter cube per kg. Okay, so in this way, the small numericals also they can ask of the conversion of the density into the volume and the specific gravity here itself. Okay, any doubt in this?
No, sir.
No, sir.
Okay, so in this lecture we try to understand this property.
Bharadwaj is host.
Bharadwaj sir is the host now.
सर कुछ पढ़ा दीजिए.
वो खुद सो रहा होगा.
बीजे
उसके रूम में जाके देखो क्या कर रहा है वो.
बीजीएम
सो रहा होगा या खेल रहा होगा।
भाई वो रात भर पढ़ाई करता है।
तू भी क्या करना।
आज
या
से
वो
करने
18
वाला
प्लस
हूँ
नहीं ना
भाई।
हुआ, उसको जल्दी सोना होता है।
काकड़े रात को पढ़ाई करते हैं तेरी ठुकाई करते हैं।
हाँ, तेरे रूम का मत बता भाई सीन।
चल भाई बात दो, मीटिंग कांड कर दे।
रुक जा लेक्चर किधर खत्म हुआ, फीस वसूल करनी है।
अब नहीं आएंगे मुझे लगता है, 37 बंदे हो गए।
आएंगे। भारद्वाज सुनेगा भी नहीं तुम्हारी, वो खुद दूसरी जगह लेक्चर करेगा।